Hello student, here is the question that for a circuit, as it is shown to you, so you have to calculate the reading of A1, reading of A2, potential of M and M. Okay, so here you can see that these are the resistance given to you, that's the 4 ohm, and these two resistance are connected in series, because if current is flowing in this, if current is coming, then it will flow, the same current will flow in this branch. Okay, so these two resistance are connected in series, so that is equal to 14 ohm, 12 ohm, and that's a 4 ohm. So their equivalent will become, that's in parallel combination, so it will be equal to R1 R2 upon R1 plus R2. So their equivalent will be equal to R1 R2 upon R1 plus R2. So 4 plus 12. Okay, so you will get from here, that's a 4 into 12 divided by 16, and it will cancel out by 16 4 times, and it will cancel out by 3 times. Okay, so this 3 resistance, and assume that this ammeter or ideal ammeter, if nothing is mentioned. So I'm just redrawing this circuit. So this circuit will be like that one. That's circuit will be like this. That's a 2 ohm, and that resistance will be equal to 3 ohm. Okay, so and that's 10 volt battery is connected to it. So current in this circuit will be equal to I, EMF of the cell, upon total resistance. So it will coming out to be 2 ampere. Okay, so here you can say that's a 2 ampere current is flowing in it, and here is the 2 ampere current. Okay, so now you have to calculate the ammeter, that's A1, and 2 ampere current will be flowing in this. So reading of ammeter A1 is 2 ampere, so it matches with your option R. So it matches with your option R. Okay, A matches with R. Okay, now second, you have to calculate the reading of A2. For reading of A2, you have to calculate the current in this branch. Let's say that current is I1 and this current is I2. So I1 can be written as that the current will divide inversely proportional to R. Okay, so here you can say that's 1 upon R, that's equal to 12 upon sum of the resistance 12 plus, because current is dividing I1 ratio I2, it will divide because potential difference between these 2 points is same. Okay, so current will be inversely proportional to R. Okay, so you will just divide this is equal to, that's 1 upon I1, that's R1, you 4, that's a 4 R1, and that's a R2. Okay, so that's R2, that's equal to 1 upon 12. So I'm just taking the LCM, so that will be equal to 12, or that will be equal to 12, and that will be equal to 4. Okay, sum of the, so corresponding to I1, the ratio is 12, and sum of the ratios is 12 plus 4, and total current which is to divide, that's equal to 2. So just divide this current, you will get that's equal to 12 upon 16 into 2. So it will cancel out by 4 times, 8 times, and from 8 it will cancel out by 4 3 times, and it will cancel out by 2 times. Okay, so it will be 1.5. So current in this 1.5. So current in this branch will be equal to 1.5, and ammeter is to read this current, that will be equal to A2 is to read this this current, that will be equal to 1.5. So reading of A2 will be equal to 1.5. Okay, so B matches with your option P. Now you have to answer potential between potential of M and N. So here is the potential M. So you can just move from here to that ground is mentioned there. So just move from here to ground. So here is the path, just you can take, here is the path you can take. Now start from this, you will write there is a potential M minus potential drop across this resistance will be equal to I into R. Just put this value here, that's Vm, okay, minus I into R, potential drop in this resistor. Current is flowing from higher potential to lower potential, so potential drop will be equal to minus I into R, 2 into 2. Okay, now move here, that's I2 current, and in this resistance current is flowing I2, that's the current is flowing, that's I2, minus I2 into R, that's 4 ohm resistance, that's so 5 into I into R, 5 into I2, the value of I2, that's equal to, if it is 1.5, so that will be equal to 0.5 ampere, because the sum of these two current is 2 ampere, so that's equal to 0.5. And from here you can that's the point M, Vm. Potential drop is this one. Here is the potential drop, this one. Okay, so here is the potential drop you have calculated. Now this is the point, this is the ground. Okay, so you can put it is equal to 0. So Vm will be equal to, that's equal to 2 plus 2, that's equal to 4, and 4 plus, that's equal to 2.5. So it will be equal to 6.5. So potential at M will be equal to 6.5. It matches with your option S. Okay, potential at N. So here is the N. Current I2 is flowing in this branch. So here is the current I2. So this is the current I2, 2 ampere, 0.5 ampere. So for calculation of N2, you can choose this path. So this is the path. Okay, this is the M point, and this is the path you can take. This is the resistance which you have, and here from here. Okay, now current is flowing like that. Okay, so I'm just starting from this point. This point potential is 0. Okay, so just move from here. That's a 0. There will be potential drop minus I into R. So that will be equal to minus I. So 7 into 0.5 I into R, and you will reach to that point. That's equal to Vn. Okay, so from here you can see that potential drop across potential of N will be equal to, just multiply it, that will be equal to 7.5, and it's in minus 3.5. Okay, minus 3.5 volt. So N potential will be equal to 3.5 volt. Okay, so just match your options. So A matches with R. So A matches with R. You have only one option there. So option number first will be your correct answer. You can check rest of the options also. B matches with P. So B matches with P. That's correct. Okay, and C matches with S. C matches with S. That's correct. And D matches with Q. D matches with Q. That's also correct. Okay, so option number first is the correct answer of this question. Okay, so option number first is your answer of this question. Okay, thank you.